Okay, folks, as Bob said, I was the NSF science rep at the South Pole in the austral summer, that is December of 2000. I was preceded at the pole, as you can see, by Roel Amundsen in December of 1911, and Robert Scott, the British team, in January of 1912. The South Pole Station is run by the U.S. through international treaty, and it's run for competitive science by any nation. You might wonder why it says under Scott, the pole, yes, under very different circumstances than expected. Namely, Amundsen got there first, and so when Scott got there, he saw the Norwegian flag. That was a bit of a bummer. Let's see. But Amundsen had the foresight to use sled dogs. And he got there and he got back in one piece. Scott decided to try using Mongolian ponies that died en route. So he had to man-haul, that is, the men pull the sleds. He had a team of 5, including himself, to the pole, and they died on the way back. When they didn't come back to where their comrades were lodged, the comrades waited, their companions waited till it thawed and went out and found them. And found their journals, which is very important because with their journals we know what they experienced. I didn't have to do a dog sled. I had a C-130 Hercules airplane flown by the U.S. Air Force. You can see National Science Foundation on the side. That's me. You can see the ground crew taking care of things as we landed at the pole. And I'll talk a good bit about those telescopes in the background there, but not at this moment. Okay. Now, in Scott's expedition in 1911 and I've got this wonderful pointer. In 1911 and 12, this gentleman, absolutely Cherry Gerard, was along, not on the pole trek, but there at the main base camp. And in 1921, after he had recovered from the trauma of this, he wrote a wonderful book called The Worst Journey in the World. And if you want a travelogue, it is just captivating. And he says there are many reasons which send men to the poles, but the desire for knowledge for its own sake is the one which really counts. If you have the desire for knowledge and the power to give it physical expression, go out and explore. That's a century ago, folks. And exploring we are, but our explorations today are scientific explorations. When I finish telling you about my trip there, you will wonder why in the world does anybody bother to try to set up science research at the South Pole. And that's because it's the best place on Earth for certain kinds of science. And I'll talk to you mostly tonight about telescopes to study the structure and origin of the universe, and about instruments to study the Earth's atmosphere and the Earth's cryosphere, cryo meaning frozen. Okie-doke. What happens next? Oh, this is an important slide. Okay. I want to position you. This is the southern hemisphere. Oops, it's off the top, but anyway, take my word for it. It's the southern hemisphere. Look at how, the latitude lines are the ones around in the circle. The longitude are the ones coming in. We're going to 90 degrees south, where all of the most minimal latitude. I mean, we're going, oh dear, wrong, sorry. We're going right there above that A, basically, where all the lines converge. Now, when you look at the southern hemisphere, you think you could get there from South America, you could get there from Africa, or you could get there from Australia, or New Zealand. And when you hear about cruises to Antarctica or about ice shelves calving and so forth, that's all really about the Antarctic Peninsula that's there. The heroic explorers and today's American and other international explorers basically leave from New Zealand. So I flew to Auckland, which is the North Island of New Zealand, then to Christchurch, which is on the South Island, and then I'll fly to McMurdo, which is basically that black dot right there. I'll give you some better pictures of that. And that's 2,400 miles, 8 hours on a C-130. And then from there, we'll fly to the pole. So that's your geography. Let's see, what happens next? Oh, I wanted you to realize Antarctica is not small. This is this is the U.S. superimposed on Antarctica, and we're going basically somewhere here in Kansas. I mean, first we're going down here, then we're going to Kansas. Anyway, just so that you realize the scale of what we're dealing with here. All right. Now, imagine, oopsie, that's not the right one. Okay. I'm supposed to be a technological person, so I can certainly deal with four. I think I should be able to deal with 4 buttons. So, we finally, after 26 hours from Chicago, I had Thanksgiving with my family in Chicago, left O'Hare Airport on the Sunday night of Thanksgiving weekend. Not a good idea. It was a mob scene. I got to LA, got on a United Airlines flight. If you work for the U.S. government, you're required to fly on a U.S. carrier. And that was 14 hours from LA to Auckland over the Pacific Ocean. Totally, that whole time over the Pacific Ocean. Got to Auckland, then finally got down to Christchurch and carried my 75-pound baggage to the International Antarctic Center. What? That's spelled with the British spelling of center. Anyway, that's where I was processed and issued my cold weather gear. This is one of my favorite slides because I love the clothes I wore. They were so warm and so useful. I had never worn a uniform before. I'd never served in the U.S. military. I didn't know how wonderful uniforms are in that they're designed for your uses. I had pockets in this parka for everything I might want to carry with me. And, always carried water, always carried extra gloves, my camera, my journals, and so forth. I didn't have these Carhartt canvas things. Those were for the construction workers. You may be familiar with those. They're very heavy canvas clothes. But I had fleece. A fleece jacket, these fleece pants. And this is not puny fleece like I've got on tonight. This was real fleece. But one of the nicest things was these overalls. These are padded overalls, and they're bibbed. So they come up, and they cover your whole front, so that when you open your parka to, get your water or something, you're still not exposed. It's great overalls. The clothes were very, very well designed. And then there's, of course, all kinds of gloves and mittens and, headgear and neck gear and whatnot. Now, it was all put in one of these bags. That's my parka there laying across this bag. I had 2 bags. One for the things that I brought, which were a pair of Levi's, long underwear, my cosmetics, and my camera gear and so forth. So I had 2 bags, and the total weight of all that was about 75 pounds. That was what we were allowed. And much of that one actually wore most of the time, which was a little strenuous. Okay, so we were loaded onto a C-130 cargo plane, and I will talk about loaded on. You'll see it in the next slide. But when I was in Christchurch, okay, this flight from Christchurch to McMurdo is 2,400 miles with no alternative landing spot. So this is 8 hours with no alternative landing spot. So the pilots are monitoring the conditions on the ground in McMurdo, and at halfway there, about 4 hours, they have to make the decision, can we land in McMurdo? Can we distinguish the ice from the atmosphere? There's no radar, you're just landing on an ice sheet. Or should we go back, which is called boomerang? For 10 days it had been snowing in McMurdo. So the number of people piled up in Christchurch trying to get out of there was really amazing. But I was fortunate to get out on my second day there. And I was fortunate not to boomerang. I made it in all one flight, one 8-hour flight. Oh, that's kind of dark. Anyway, can't really see it. Yeah. Oh, yeah. Oh, sorry about that. Yeah, okay. Because you've got to see this. 40 of us passengers were crammed in the front of the C-130, and you sit in this webbing, these...
Jump seats.
Is that what they're called? Thank you. Well, I didn't jump much in them, but anyway, they hang either from the side of the plane or from these metal tubes there. And you're sitting bun to bun with your neighbor and knee to knee with your across the way neighbor. And my across the way neighbor was Bill Hopestaffel, a astrophysicist from Berkeley with a size 15 foot. So we had our feet interlaced and our knees up against each other. But this picture actually is after we were allowed to stand up. And you can see that folks are wearing earplugs because the noise level on these airplanes is the pits. Now, these airplanes are flown by the New York Air National Guard folks. And this was a crew going down to the pole to do their flying on behalf of all of us. And as soon as the pilot turned off the seatbelt sign, they knew. They split and went up and lay on the cargo. Behind us, the 40 of us crunched in the front, were 3 enormous pallets of cargo. And you can see they're lying on carrots and onions and potatoes and whatnot. But, and the scientists were either standing up reading or working on their computer, and I was being a total novice. I had brought along the Spanish vocabulary I was going to memorize on this 8-hour flight. Well, that didn't last long, but anyway, I did make it there. Okie-doke, whoopsie, this has to go. I went too far.
Were you expecting to be speaking Spanish at the
No, this is just a little mission I had set I was going to come back a very slim señorita. Well, didn't work. Okay.
You skipped over one.
I skipped over one? I don't think so. Am I not doing this? Oh, I did skip over a very important one. Nope. All right. Let's now.
What was the thing about the supercomputer?
Oh, it's the one that takes a while to load. Sorry, I got to go back because this one is important and it takes a while to load. Okay. Antarctica. We're landing right there on Ross Island, a volcanic island where McMurdo Station is. South Pole is obviously the convergence of all these lines. We're coming from New Zealand down here. Notice this is the Antarctic Circle. You've obviously all heard of the Arctic Circle, but there's an equivalent Antarctic Circle. And I want you to just keep in your mind the Southern Ocean. It's a very important ocean, and you're going to be hearing a lot about it in the discussion of climate change, because it is the cold water that flows under other current and creates the currents essentially in the ocean. It creates eventually the Gulf Stream and comes up to Iceland and brings the waters and the climate that keep Europe warm. So you'll be hearing about it.
Where's the magnetic pole?
It's more over here, and it is different. The South Pole is the geographic South Pole. It's the spin axis of the Earth. But that is offset from the magnetic pole just by a little bit. It's actually in an area that the Russians control. Okay, so fix this in your mind. Now, McMurdo. Okay, we land at McMurdo. As I said, it's a volcanic island. There's Mount Erebus, an active volcano. And this is the major logistical hub for the U.S. activities in Antarctica. And it looks like sort of a mining camp in Alaska, actually. This picture I took from a helicopter on another trip I was on, but that gives you a sense of what it looks like. Now, let me see if there was something else I wanted to tell you about it. Okay, yeah, I have my cheat sheet here. Now, McMurdo itself is at 77 degrees south latitude, and we're 2,400 miles from Christchurch. We're going to the South Pole at 90 degrees south latitude, another 850 miles. Okay, let's see, what's the next one? This is where we land. It's out there on that ice sheet where we landed. That's Mount Erebus. And this is called the NSF Chalet, where you get an orientation, but it's, these flags are the 12 signatory nations of the international treaty. And that's a bust of Robert Scott there. Let's see, what is my next? Okay, now this next one is good. Okay, here we are today. This is Robert Scott's hut from 1902. Really pristine, undecayed, it's frozen. On the porch, a picture I didn't show because it was a little dark, are still the mummified seals. So that's Robert Scott's hut. This is modern day McMurdo. And just keep in mind that absolutely everything there has to be brought in by ship or airplane. This is the harbor. In this picture, it's frozen. But once a year, a U.S. Coast Guard icebreaker comes in. And this is the Polar Sea icebreaker. I had the opportunity to fly by helicopter out to it and spend a day on it. And you can see that it is cutting its way through the ice toward McMurdo. And this is a picture I took from the helicopter window as we flew away from the icebreaker. I just think of this as the loneliness of a long-distance icebreaker, sort of. And there they are out there, the captain and a whole bunch of crew that are about 19 years old. He was not having too much fun with them, but anyway. Then on New Year's morning, this was as I was returning from the pole, the icebreaker made it. There it was at McMurdo, and had opened the harbor there so that a supply ship could come in. And this is really necessary because the supply ships are bringing in fuel and very large pieces of equipment, things that it's really inconvenient to fly in. Everything that is brought in is planned for, and then every bit of waste is carted out. Absolutely everything. If you pack it in, you pack it out. But another reason I wanted to show you this slide is to show you helicopters, because we had not only airplanes, we had these helicopters. And McMurdo is the logistics central point for research by the U.S. in Antarctica. And these helicopters are used to transport researchers out to remote sites where they're doing their research. And I had the opportunity to be on a helicopter and go out to what's called the dry valleys. This is off of McMurdo on the continent. And these valleys are dry because enormously strong winds blow down from the Antarctic plateau and scour these valleys clear of any snow. So you can see that this research station, they've been supplied by helicopter. They have these huts, these tents. These are called James Ways, and they were a Korean War vintage tents that were used also at the South Pole. Then they have these various little huts for, instrumentation and different purposes. One of the things that some of these research sites like this look for is evidence of biota, of some kind of life out there. And I have to tell you, there's not much out there. Let me see. Plant life in Antarctica is limited, consisting mostly of algae, lichen, and mosses. And there are only a few known species of flowering plants. As far as animal life, only microscopic animals such as mites and worms and insects exist on the land.
There's no penguins?
Nope, no penguins at the South Pole for sure, but in Antarctica, the Southern Ocean that surrounds it that I had pointed out to you is full of life. It's full of phytoplankton and zooplankton and fish and squid and seals and whales and penguins and all those things. But they are essentially sea life. They aren't native to Antarctica. They're there feeding from the sea. And of course, no polar bears. We're at the South Pole, not the North Pole. And no polar bears, no mammals, no vertebrates of any kind. Anyway, so let's go on and get to the South Pole. I landed there. Obviously, I didn't take this picture. This is another plane that landed. I was not on this plane. This was another plane that landed. It lands on skis, hydraulic skis. I love this. This is the ground crew. This is the firefighting equipment. So there we are. There were some things I wanted to tell you about this. All right. We're landing on solid ice that is almost 2 miles thick or deep. It's so heavy that the bedrock underneath is thought to be depressed and be below sea level. But we're on a real continent. This is not like the North Pole where it's ice sheets floating on water. The altitude is 9,300 feet, but because of the rotation of the Earth, we're at the Earth's rotational spin axis, the atmosphere is actually thinner at the poles than it would be at the equator at an equivalent altitude. So we're spinning the air up toward the equator, so that the barometric pressure at the pole that is, the air is actually thinner than would be comparable here at 9,300 feet. So it's called the physiological altitude, and it's between 10,000 and 13,000 feet. So it's like working at the ski basin or at Baldy, depending on what the barometric pressure is that day. Yeah, I'll get to that. Thank you, Eve. Now, okay, I want to give you a sense of what it looks like. I'm out at another facility where I took this picture, but this is the main area, and I will be lodged under that dome there. Most people live out in tents out on the ice. This is the new station that was under construction when I was there. This is a runway. Don't go past there. And lots of stuff is stored out on the ice. So I wanted just to give you a picture of what it looks like when you land. That's what you see. Now this is the dome where I was housed. This is the entrance. You enter through a tunnel. One of the things that intrigued me about this dome is on either side of this tunnel are these, is a big cross section there. And this is an area that holds the fuel bladders that are there to fuel the power station. The power station is over here, and various kinds of garages and mechanical areas. You have to have some place where you can repair equipment. And that's, you know, tricky at minus 25 degrees. It's a little uncomfortable. Anyway, once you go inside the dome and walk through the tunnel, at the time I was there, and I'll show you the news station, this station had been in service for well over 30 years. It was well beyond its lifetime. But inside, it's the ambient temperature, minus 25 or whatever it's going to be that day. It doesn't vary very much. And I lived in that, my sons call these reverse meat lockers. And they really are. They're warm on the inside, and outside it's cold. So I lived in this meat locker right there in a room that was about 7 by 8. It had a bunk bed that was raised up off the floor. You want to get up is where the heat might be. Under the bunk bed was room for your baggage, and I had everything a human needs, an electrical outlet and a reading light, and a bench on which I could lay my clothes, because I wore so many of them that the trick I learned was to lay them in the order you're going to put them on in the morning. Otherwise, you'll get mixed up about, you'll be ready. You need to put on your overalls last and your socks first and so forth, and build all this up. So I had a bench for that. 8 by 7, yeah. It was very commodious. Anyway, this was the VIP housing. I was in there with a flush potty. There were 2 on site. Wow. And other people in there were the main station folks and the power plant manager. I never complained for 1 minute. The potty, I'll talk, okay. There's one potty there. It was a room with no door that had a sink, a urinal, a toilet, and a shower. Now, the shower had a curtain and the toilet had a little door, but the way we handled it, and it worked very nicely, is that people would stand out in the hall and see what shoes were, they could spot, and just be courteous of other people and wait till the facility was available to them. We were allowed 2 showers a week at 2 minutes each. Which really wasn't a problem because the humidity at the pole is 2%. It's extremely dry because it's so cold that all the water has been frozen out of the air. And you didn't really sweat very much. In fact, the challenge was to stay hydrated. Drink enough that you're hydrated, but not enough that you have to go to the bathroom. So, you get used to that. Now this meat locker is where the science offices were and the communications center and computers. I worked in there. The galley, which was the mess hall, was down a little further, and I'll show you some pictures of that. We had a wonderful time there, but the last thing I want to show you here is there was one of these meat lockers was called a Freshie Shack. It was a do not freeze shack. Because if you're bringing in foodstuffs, they arrive on an airplane, they have a snowmobile out there with a sled to meet them and whisk them into the do not freeze shack. Because if you want lettuce or an orange or anything like that, it has to be brought in and somehow manage to be put in the do not freeze shack before it freezes. So it's just fine. Actually, also above where I lived, this was a greenhouse where they grew a few things. It was, you know, we had lettuce once a week, so, you know, everybody got a leaf. But the food was actually very, okay, I was there in 2000. They were building the new facility, and I took this off the web. This is the new facility. Now, is that plush? I was over there in that thing, and here they are. You know, and there's still tents out there for other people, but it's a wonderful facility. And you can notice that it's up on, these are poles, and they're actually hydraulic. So they, as the snow blows, and eventually, the snow has blown so much that this dome is almost totally covered, and it's in risk of collapsing. And of course, they expect the snow to blow and pile up on the new station, but they can lift this station on these hydraulic poles that it's on. That's the theory. I sure hope it works. I haven't seen that because that was dedicated in 2007. But I want you to also notice over here, this whole area, as I talked about I talked about the entrance to the dome, this area is the power station. And this is a plume from the power station. And there's nothing at Antarctica more important than the power station. It even beats out the mess hall in importance. But notice also that the plume from it is blowing in a particular direction. There is a prevailing wind at the pole, and that means that the atmospheric sciences facilities are downwind of that, so that they're looking at the cleanest air on Earth. Let's see, what's next?
Do they use photovoltaic?
Huh?
Do they use photovoltaics for electricity?
For electric, do they use what, Randy?
Photovoltaics.
What?
Solar cells.
Oh, no. Actually, no. They had a choice about what they would do with the new station, and they chose petrochemical. I don't know what the diesel mix is, because they use the waste heat to melt ice to make water. So they didn't want to be efficient. They wanted to be inefficient and have this waste heat. And I didn't bring my slide of the water well, but having water is a big deal. And they use the waste heat. It's designed so that all the waste heat from the power plant is used. All right, well, we were in this old kitchen, but it was really fun. At the time I was at the pole, there were 220 people. It had been built to accommodate about 120, but you know, what's the problem? They fed us 3 meals a day. People worked around the clock. They worked 9-hour shifts. So you've got an 8-hour shift and you have an hour or 30 minutes on each side. So people are working around the clock on these 9-hour shifts.
Was there any dark?
Huh?
Was there any dark?
No, there's no dark at all. This is the austral summer. Yeah, sorry, I should have brought that out. The sun is up, and it is inclined in the sky on the longest day of the year, December 21st, at 23 degrees inclination, and it just rotates around. And if you want to take a picture and the sun's in your face, you wait 12 hours and the sun is in your back, and you can get the ideal picture. So people are working 24 hours a day, and as I said, it's really a 3-month work year, or work season, November, December, and January. And people are, frantically working.
Is it vacated the rest of the year?
No, there are about 30 people that winter over to keep it functioning and to keep some of the experiments going. And wintering over is not fun, but some masochists really love it. I couldn't have done the total darkness.
Winter is a total dark.
Total darkness. Total darkness.
After November.
Well, it's not. The sun will come above the horizon. It'll be very low in the horizon, but the temperature doesn't rise enough that airplanes can fly in until about middle of October. And the last planes leave about the middle of February. So it's a problem with the temperature and the lubricants on airplanes. Lubricants on airplanes don't work very well below -50. So that constrains the year a bit. And as soon as the teams are able to fly in, they have a lot of stuff to fly in. As soon as the sun is even up a little, the people who winter over are out preparing the runways so that planes can land. They're out getting the facility ready for folks to come in. There's a lot of work to be done. And of course, they also have the motivation that they get to fly out. So that'll really make you work.
How long were you there? How long were you there?
I was there for a month, the month of December. Yeah.
Karolyn, what did you say they used for fuel?
It's a petrochemical. It's some kind of diesel fuel. It comes in this enormous bladder that is designed to fit just inside a C-130, and then it's stored there at the pole. These big bladders of fuel. Yeah. Now the fuel for the humans, you'll see here, there's always cereal any time of day or night, except there's of course no night. Always soup. They serve in these two little areas, and the food was wonderful. Very high protein, a lot of meat, very sturdy food, a lot of liquids. We had what I called the pink stuff, the orange stuff, and the white stuff. The lemonade, the tang, and the milk. But you can see also the gingerbread houses that some folks had prepared for our Christmas celebration. This, huh? Yeah, the garlic and whatnot. The food was excellent. And they had 3 long meal periods per day, and then they had what were midnight rations, mid-brats. So if you were working in one of the off, schedules, you could always get food. You would come into the galley here, and they had a refrigerator that always had food in a microwave and so forth. So people were really eating around the clock, and nobody suffered. The food was excellent. And we even managed to have joyous times. This is Christmas Eve. The galley seated 80, and we were 220, so we ate in 3 shifts. So when you were eating, you were waited on by your colleagues, and when they were eating, you waited on them. And that was really true in everything that happened at the pole. You had a primary job, and then you had secondary jobs. And my primary job was really threefold. Every week, I sent a report to the NSF of all the science projects going on and how they were progressing and what the issues were and how things were going. I managed and oriented and handled distinguished visitors who came. These were people from Congress or from the military or from other agencies, NSF or other agencies, so that the scientists wouldn't be interrupted all the time with questions about what are you doing. I did all that orientation for them, which means that my primary work of gathering information about everything that was going on was very helpful. I learned it all. And my third job was to organize science talks and little educational outings for everyone, because we had 50 scientists at the pole, but we had another 170 either staff people or construction workers, and they were interested in what was going on, And so I arranged talks so that they could know what the science was that was going on and feel involved in it and understand what their effort was going toward. So that's why the NSF sent me there. I mean, I'm a physical chemist. I'm not an astrophysicist or an atmospheric scientist, so this was relatively challenging, to say the least. Okay, this is Christmas morning. And this is the race around the world, around the South Pole marker. But every year, the crane is brought out to fly the flag of the U.S. and the POWMIA flag. This is the station that's being built when I was there and that you saw the completed version. So people are gathering for the race around the world. I brought my T-shirt from every race has to have a T-shirt, don't you think? So here's my T-shirt from the race around the world. Oh, you can see the course. You can see the runners back there. This guy, this is the guy that was sitting next to me, in front of me in the airplane with the size 15 feet, Bill. And he's an astrophysicist that works out at these telescopes, and I'll show you more about the telescopes. But you can see the track around there. And here's the South Pole marker where I was in the first picture that you saw. Now, the thing about this picture that's interesting is what's going on right there. This is the South Pole marker for this year. Every year, the ice moves 30 feet, 10 meters, and they put out a new South Pole marker. And here you can see the South Pole markers from previous years. So in 240,000 years, let me get this straight. Yeah, and in 120,000 years, Bill will fall off the edge of Antarctica. Now, most of the facilities, some are in the dome area where I live, but the others are set out further away for several reasons. This is called the dark sector, and it's out away from light pollution. I'll show you in a minute the clean air sector that's out away from, the airplane exhaust and so forth. Yeah, Bill.
Are you saying the U.S. has a fence around the pole and there are no other facilities, or is it shared?
It's shared on a competitive basis with research. You compete your research projects, and any nation can have a research project. Most of them are big international collaborations. But we're tasked through international treaty with developing and supporting the facility. And actually, I didn't mention this before, but the staff that supports the facility are managed by Raytheon Polar Services out of Englewood, Colorado. That's everybody, that's cooks, power plant, you name it, everything that you need in terms of support staff. Scientists fly in, they're transients, and they want to do their science, and they want it to work, and they want to have that crane when they need to hoist their equipment and so forth. It's all extremely carefully scheduled, and resources are limited and used to the max.
How do they handle medical?
Medical, yeah. In a minute, let me talk about medical in a minute. Let's go to do astronomy first, but don't let me forget, Eve. I'll talk to you about medical. We had one doctor there for 220 people. You go through, the doctor goes, you have to physically qualify. It's called PQing. And I mean to tell you, they check you over from top to bottom. They really want to know if you're physically able to do it. They want to anticipate. But how can you anticipate if your gallbladder's going to go out or whatever? Anyway, this is the dark sector. Let's see. Now, the overriding question when you look at all this is, why do science at the South Pole? What is so special about science at the South Pole that you have to go down there and do it there? Well, as it turns out, that is the ideal location for doing some particular observations. The conditions for observing in the radio and millimeter frequency, microwave frequency, are better than anywhere on Earth. And to get any better, you'd have to go into space. And believe it or not, space is even more expensive than the South Pole. The atmosphere is transparent and dark throughout the infrared and millimeter wave spectrum. And this means that all the water vapor almost is frozen out of it. Now, water absorbs microwaves, the microwave frequencies. That's why you put things in your microwave and water boils. So if you want to do microwave frequency astronomy, you need the driest place you can get. And the pole is the driest. It's not just that it's dry, the air is very thin as well, and it's very stable. Stars don't twinkle. You know, it's very stable at the South Pole because you don't have the temperature variation of the sun rising and setting, which is what causes a lot of atmospheric instability. And particularly in the winter, when it's cold and dark, it's a great atmosphere for observing. Now, the latest facility, which wasn't built when I was there, it was still just a gleam in the eye of the astronomers who were working here. This is a 10-meter telescope called South Pole Telescope. That's the original name. And they are really looking at the cosmic microwave background to try to understand the origins and structures of the universe. And they started that work originally in this facility, and I'll show you a little more there. Now, these red objects in the foreground are a project called IceCube, and it is a neutrino observatory. Now, these aren't neutrinos from the sun. These are high-energy neutrinos that come from early things in the universe, early actions in the universe. Now, this is a row of drilling sites, and this is then their computer center. Now, let me show you. Bob put this slide in here. When he was at NSF, you guys were funding some of this stuff. Anyway, IceCube is a collaboration. And these neutrinos are so energetic, zillions of them come through the Earth and through you all the time. And detecting them is very difficult. They come from exploding stars and, from black holes and so forth. So if we want to understand what's been going on out in the universe, these neutrinos are something that we would like to be able to capture. And what has been done at the pole, which is interesting, is I said the pole was an ice sheet about 2 miles deep. The ice is quite pristine. So what they have done is to set aside a 1 kilometer cube. They drill down with hot water into the ice and then put down a string of these detectors, and you can see the strings here. And if a neutrino comes along, it goes through a series of reactions, and it finally gives off a blue light that they can measure. So this is a big detector, 1 kilometer on a cube, on a side, at the South Pole, trying to understand the direction from which these high-energy neutrinos come, and then basically back-calculate what the structure of the universe was at the early time that these were emitted.
On average, how often do you see a neutrino?
Yeah, I don't know. Do you know, Bob?
You see about 30 a day.
Yeah. Now, this is the microwave the telescope that was there when I was there. And one of the thing I enjoyed about this was they were redoing the telescope that should be sitting in that mount there. So they erected this kind of Quonset hut because it's minus 27 degrees, but the wind is about 14 knots, which makes the wind chill about minus 46. So if you can put your work inside that hut, you're gaining 20 degrees. So this was the day, a wonderful day. This is the Viper telescope, and they had been working on it in this hut to upgrade it. And this was the day they lifted it into its mount. And I just loved it. I mean, the people who are working the crane, the technicians, are so skilled. And these are the scientists. That guy actually happens to be from Illinois, where I had also been. So I just enjoyed this day very much. But while I was watching them lift Viper telescope over there, I noticed that over at this other little structure, they were having a fire and rescue drill. And the point is that every team at the pole was working all the time that you aren't sleeping, which you sleep as little as possible. But people have double duties. I mean, these folks may be a computer technician, a cook, whatever. They're doing a fire and rescue drill out here. Now, we had one doctor, and we had a team that formed the emergency medical team, the EMTs, and each of those EMTs was something else. I mean, they might be a scientist, or they might be, work at the power station, or, be a cook or whatever. But one night, I say night because I was sleeping, but, other people were up, it was light. We get the notice through the PA system and through telephone that calling the EMTs to come. And it turns out that a construction worker was up 2 stories on some scaffolding and hurled a board off, and a nail on it caught on his clothing and hurled him off. So the team went out, immediately assembled, went out and brought him in to be, his hand had been broken, to be cared for. And then he was flown out to McMurdo as soon as a plane was available for him. And he did fine, he recovered, but everybody who went out to deal with him was trained in emergency medical procedures, and then of course the doctor set his hand and so forth.
Do bacteria live around there?
Huh?
Do you have bacteria living around there?
Not much.
So he wouldn't get infected.
Nope. Nope. Now, okay, let's switch over and not think about astrophysics, but think about atmospheric sciences. I love this picture. I downloaded this from the web. Obviously, I wasn't there in the winter. But this is the Aurora Australis. In other words, the southern lights. And this is a good place to study the interaction of the solar wind with our atmosphere that creates the southern lights in this case. So we're studying the effect of our sun on our atmosphere. Now, okay, the bright spot there is Jupiter, and this is the Milky Way. And there are more stars in that sky than we see in New Mexico, and I think we're pretty lucky. This is the clean air sector. This is the Atmospheric Research Observatory, and this is downwind from the main dome area, so the wind is blowing away from the dome. And this is just chock full of instruments for measuring all kinds of things. Here I am up on the top of that, looking back at the dome, looking back at the runway, and the new site the new station being built, and the power plant, and so forth. So there's a lot of work done on measuring the composition of the air in what is thought to be the cleanest air on Earth, and I have 2 vials of it that you may hold. But I'll tell you, when an airplane lands, which does once a day, all the needles on these measuring machines spike. And I think about that a lot. I think about what one airplane does landing to the air quality, and then I think about O'Hare, where a plane lands every 26 seconds. But anyway, it's important to know what clean air is so that you have a baseline for comparing everybody else's air. Now, you've probably all heard of the ozone hole. And this is, it refers to an area in the stratosphere where the ozone has been destroyed through chemical reactions. And as you know, I'm sure you all know this, ozone absorbs ultraviolet, and so it shields us, humans on Earth, from frying from ultraviolet. Now, it's actually, I don't need to go into this, but the fact that it's here in Antarctica is due to the cyclonic nature of the winds in Antarctica. In the summer, they're cyclonic in one direction, and in the winter in another. And in the winter, it amasses through this, we're at the spin axis of the Earth. So through this spinning and through this cyclone, it amasses all these chemicals and whatnot. And then in the spring, when the sun is there, they react in photochemical reactions and destroy the ozone. So, and that does not happen at the North Pole because it does not have this vortex, this cyclonic vortex at the North Pole. Okay, whatever. NOAA, are you ready?
Yes.
Okay, the National Oceanographic and, National Oceanic and Atmospheric Administration, NOAA, is down at the South Pole too. And they are using balloons, they're sending up balloons that are instrumented to measure ozone concentrations. And I went out one day when they were at the balloon inflation facility, BIF. Everything has an acronym. And saw them release one of their instruments for measuring ozone. Now, all of that information from those instruments comes back and has to be processed. So this is a picture from the new facility, and this is a lab. This is just an example for you of a lab that is processing data from instruments used to doing various measurements in the ionosphere and the magnetosphere. I don't know what they are, and I don't know what those instruments are, but the data all comes in, and the Antarctic program is very proud that they have a new Earth station to link, an Earth station link to the NASA satellites so that they can send data back to researchers' home bases all over the world faster than ever before, more of it. They can send 200 gigabytes per day to universities and various institutions. They have a parallel Earth link for communications for things like email and teleconferencing and video conferencing. A lot of the medical work is done actually by video conferencing and by sending information to the states for analysis. I know you all know about the doctor who had breast cancer, and so I won't go into that, but she discovered in the winter, in the black as pitch, a lump in her breast, and she decided to biopsy it and send the pictures from the biopsy to Indianapolis where her physician was. And the amusing thing is she chose the person to biopsy it, she chose the welder because he had very fine control of his hands, and she trained him to do the biopsy, and he did it. So people have multiple talents. You never know if you're a welder, what you might be called on to do. Okay.
Do they get those sensors back, or is that a one-shot deal?
It's a one-shot deal in that particular case. It's going up very high, yeah. All right, one day, we're just blithely going about our work, and two Norwegians ski up. Well, they hadn't been able to radio us because their radio was broken. This is Rolf and Eric, 25-year-olds, skiing across Antarctica. They had already been out 60 days. They had left from the coast that is below Africa where they had wintered over with a doctor and an engineer, and then they set out as soon as possible. And they had already skied Norway and skied Greenland. So, Antarctica was the next natural thing. They were wonderful, articulate, just delightful guys. And this is their gear. I mean, they're actually parasailing. And I'll show you a slide where you can see their parasail better. But their gear's in this little canoe type thing. And they gave a talk. Well, I'll show you the next thing. They didn't disrupt their schedule. They stayed in their own accommodations and ate their own food. And you can see they have their Norwegian flag, and you can see their little cradles that they have their gear in. And so this is what their life is out there. I mean, except, they'd been 60 days without seeing a human being. We gathered in the only gathering space we had, which was a sort of a gym, and asked them questions. And they were so gracious, and their English was terrific. And people asked them everything they could ever imagine. And a lot of technical questions, but asked them, gosh, what do you think about when you're out there parasailing 18 hours a day? And one of them said, oh, girls. They were just delightful and so tolerant of our questions. Of course, we asked them about their food, about everything. And, well, okay, so they sailed away. All right, these are their parasails, and here's one of them. I don't know if that's raw for Eric, and his cradle back there. And they're headed to McMurdo, 850 miles. And they made it. Yeah, they made it fine. They got there, caught a boat. I don't know if they caught a boat or a plane out, probably a plane. No big deal. And they were gathering this information, doing a lot of monitoring of themselves and of their environment for the Norwegian Antarctic Society studying. So it's about time for me to leave. Fortunately, I don't have to parasail. I have the U.S. Air Force. And this is a picture back at McMurdo. Actually, we're at the, this is actually the New Zealand airport there. I mean, not it's the New Zealand base in Antarctica. And I'm getting ready to leave. And I have the luxury of sitting in an airplane looking out at the Antarctic continent as I fly away. And there it is. I wanted to impress upon you that we have really only scratched the surface. Here is McMurdo. The pole is about right there. There's all this other stuff. We just saw a little snippet of what's going on in Antarctica and all that it is tonight. But we looked at it for the same reasons that Scott's expedition a century ago did, to pursue knowledge for its own sake and to go out and explore. I'll take any questions.
Right.
Question and answer period?
Yes.
100 years ago, the international language for science was German. What did you all speak?
Oh, everybody spoke English.
Everybody spoke.
Everybody. And I tell you, these Norwegians were really impressive. The two of them, their English was 100%. The only word that they did not know and had to look at each other to translate was the word gator, which is these kinds of leggings that they wear. I didn't even know that word.
I never wrote down the moon rocks that have been discovered.
Well, they do discover rocks. Yeah. They've just fallen down there, and there they've sat. And they go out and look for the meteorites. But
Collecting expeditions.
yes, they do go out. Yes, correct. But it's a big continent. I mean, you're going to go out and look for a rock on that continent.
Karolyn, is gravity affected at all? Any different, or is it the same?
I don't
as
think so.
everywhere else?
I don't think so, Eve.
Gravity is the same?
Yeah,
all over?
uh-huh. Yeah, the air is thin, but gravity is the same. Hi, neighbor.
Can you speak about how much it costs to do a science experiment?
Oh, wow. I don't know. I mean, when you apply for the grant that you use to apply for time and for facilities is a very elaborate grant where you have to cost out everything. And I don't know how they deal with the budgeting for the cost of science support for what Raytheon Polar Services provides. But you could say I'm going to need 2 days of the crane, for example, and I'm sure they have a dollar figure for that. So if you're lifting the Viper telescope, you've got, you have the crane. But what you need to upgrade the Viper telescope, for example, is in your grant to your institution that, and it's for all the part materials and time and everything. And that is a separate award that is to your institution in the States. And that's interesting because I work for the government. My way was paid, and I don't know how the grants go about costing out transportation, for example. I don't know. Do you have any idea how that's handled?
No, I do know that the budget of the U.S. Antarctic program is about $100 million a year.
Yeah, it's an expensive business.
Does the Air Force foot the bill for the flying? Or does,
The Air Force Air National Guard of New York is...
that's part of the training? Yeah. That's how they rationalize it.
Well, they are C-130. The Hercules cargo plane is still used extensively today. It is the work engine of cargo transport in the military. And that particular group does C-130s.
You said it's 100 million. I think you said there was about 100 scientists, something like that?
Well, at the time I was at the pole, there were 50 scientists, but that's in that one slice of time.
Well, anyway, I'm just trying to estimate it. It'd be about, we could figure the rough estimate of $1 million a project.
Oh, yeah, it's probably more than that. I mean, there's all the people that don't get to come on the ice, we call it on the ice, who work on a project. A graduate student who gets to come down considers him or herself very lucky.
Each of these experiments represents a big team of people who don't come. So it's just that money's distributed over a lot.
And the people who win are over are only those who are needed to do maintenance on a piece of equipment, on a telescope or so forth, and make sure that the data keeps flowing. Let me ask Gina.
You mentioned that the Russians have a station
Mm-hmm.
with a magnetic pole. Do they have a similar kind of program?
No, the Russians have a brutal program, I'm sorry to say. Their people don't just winter over, they stay there for 2 to 2.5 years nonstop. They have a real alcoholism problem. They don't have women there. The Americans were real path breakers in having women at their stations. Well, there weren't a lot of us, but I felt perfectly comfortable. But then I've always worked in a man's world in science. But the Russians, interestingly, have a site that's over Lake Vostok, and I didn't talk about that, but that is the largest lake in Antarctica, and you could ask, why is there a lake in Antarctica? Well, it's underneath the ice right against basically the bedrock. So it's ice that's been melted by the earth, and turns out there are a lot of lakes now that they know how to, gosh, I don't know what technology they use to find them, but they do. And there's a lot of lakes, and there's a huge interest in drilling into these lakes and seeing what's down there, seeing if there's some kind of primitive life down there. But If you drill, how do you not introduce contaminants? Real problem. So the British are drilling in a smaller lake in this austral summer. You're going to experiment with the technology of trying to go in, just pierce the surface, let the water come up, extract it, and it freezes, obviously, and then studying it and see if they think that technology can explore the water in these lakes without contaminating them. Because it's interesting to think what's down there. Yes?
Your pictures were so clear, and the atmosphere looks like the sun is so bright that I'm wondering, in the summer, I wouldn't have known, except for the snow and the warm clothing that the people were wearing, what the temperature might be in the summer, and as opposed to the temperature in the winter.
Well, the temperature in the winter gets down to about minus 86 below. And we were at about minus 25 to 27 most of the time. Huh? Fahrenheit, that's Fahrenheit. It's cold. If you're going between buildings, you use the buddy system. Have somebody with you, particularly if you've been drinking at the Christmas Eve party. And it's a severe environment, and you take precautions. You try to be as sensible as possible and not endanger yourself or cause other people to have to come rescue you. And
Fireplaces, all those fireplaces?
Oh no. Oh no. No, there's the heating system from the power plant, and my room was about 60. In my office, I wore glove liners, the kind where your little fingers stick out the end, so I could type. And I always wore long underwear all the time, jeans, and then maybe a fleece over it. The floor was temperature on the floor was about 50, but if you have on good shoes, I was never cold. You just take care of yourself,
Cold enough to take like boiling water or something, throw it, and it freeze?
Might, I don't know. The most crazy people were trying to do snow angels. That was really, really stupid. Yeah, you had a question, David.
Yeah, my question is do people share the science information?
Absolutely.
Like all nations just share?
Absolutely. I didn't talk about the Antarctic Treaty. It was signed in 1959, and it's still binding, and more nations have joined. There are now, I think, 26 nations. And it says that all uses in Antarctica will be for peaceful purposes, no military. That all science is open and will be shared. That the environment will be protected. Every waste material has to be shipped out. And other requirements for cooperation. And it's very clear. I mean, when we were in McMurdo, it was very clear that the New Zealand base, which was the nearest thing to us, was sharing their facilities and we with them. And that's the way it works, because being stingy wouldn't be a good idea in this environment. Yeah, Roy.
Do they have a program for young people as interns?
No, not per se. There's a program for teachers experiencing Antarctica, TEA, and two of the teachers in that program were actually at the South Pole when I was there. They were both physics teachers that had the opportunity to go there and work on an experiment. There is an artist and writers program, so every year there will be photographers or writers and so forth in Antarctica. I'm trying to think if there were any undergraduates. Yeah, there was one undergraduate that came with the University of Chicago program. But But that was, you know, this guy had been working with the telescope project at the University of Chicago, and they let him come down and be their flunky for a week, which I'm sure was fine with him. But there were graduate students, postdocs, and professional staff and faculty from mostly universities. The U.S. program is mostly universities. Some of the European programs are mostly from institutes that are very specific for Antarctic studies. For instance, Norway has a very active Antarctic Study Institute.
Have there been any big surprises about research that's gone on down there that no one sort of imagined?
You know, this stuff is so thought about in advance, so deeply defended and developed that, you know, I think about the DAISY telescope that was looking at the cosmic microwave background, and the theory predicted they would see a particular little hump in the curve they were measuring, and they saw it. So that was telling them that the universe, according to the theory that they were testing, that the universe expansion of the universe is accelerating. So, you know, you have to get a science grant, you have to argue why a body of science says that this ought to work, or some theory predicts it, and you know how to test that theory if you just have the opportunity. So you have to argue that, and then you get awarded the opportunity, and you have to plan. I can't impress upon you how much planning goes on, because you have this compact time, 3 months. You have to schedule all your materials to be shipped. Think about the person who does the scheduling for the airplane, and what cargo goes on it, what people go on it. And think about just people leaving at the end of the summer. They can't all wait for the last airplane. So it's all very carefully scheduled and regulated so that you get the materials in, waste materials out, people in, people out, and so forth. It's a real feat, yeah.
I think we have time for one more.
Well, this young lady.
Have they found many fossils of animals from like 1,000 years ago?
They do find fossils in certain areas, not at the South Pole because they've got this 2 miles of ice there, but in the dry valleys that I showed you the picture of, where the land has been scoured clear of snow, they do look for fossils because they look for evidence of when Antarctica was actually a temperate continent, not a frozen one. Yeah, and they find that evidence. Bill?
Some marsupials in the dry valleys.
They-
South American, Australian, and the Arctic.
They found marsupials?
Late Mesozoic.
Oh, fossils of them. Yeah. Antarctica and Australia were attached at one time before continental drift. Okay, well, thank you all very much.
So after this evening, a lot of you can say that you were in Antarctica. So we're all delighted that you had